Welcome to our third video of creating a Lisp with Claude and Swift. So today I want to add support for reader. Most Lisps have what they call a reader. It basically encapsulates the lexer and the parser, and it lets us have things like reader macros, which will let me demonstrate a reader macro. So here's our closure REPL. Now normally when you type in a list, it tries to evaluate the one. It thinks it's a function. But if you type the quote character and then do 3, 4, it actually returns the list. And the quote is a reader macro that actually translates into quote 1, 2, 3, 4. And you can actually see that by using the read string, which is a function of the reader, and passing it in the actual string here. And then when you evaluate it, you'll see the quote. There you go. So that's what we want to shoot for. So we'll start with refactoring things to create a reader. So here's our prompt. Create a reader class that encapsulates the Lisper and parser. Its purpose is the same as Clojures or any other Lisp's reader. It should have one main function called readString that takes a string and returns the AST for the string passed in. In our case, the AST is represented by the expr enum. Our interpreter in swishkit.swift should use the new function instead of using the lexer and parser directly. readString should also throw an exception if it encounters any errors, and callers should catch those errors and report them or pass them on. All right, so let's go. Let's accept that. And I forgot to put in plan mode, but let's see what happens. All right, put it in plan mode. We'll see what it does. All right, it's through looking at the code base. And it will soon have a plan. Here's a plan. All right, so the lexer and parser are currently used directly in SwishKit. A reader class will encapsulate this pipeline and provide a clean read string API that returns parsed AST. All right, we're going to create the reader class. I like that signature. It's going to update SwishKit to use the reader. All right. That looks good. So let's just proceed and let it just do its thing. Again, over here you can see the files that get modified. We've got the reader. We've modified SwishKit. It's going to run the tests. All the tests pass, which is nice. It didn't have to change any specific tests, which is a little suspicious, but let's go run the test ourselves. And it's good. And let's run the REPL again. Make sure things are working. Looks like we're good. Let's look at the class, at the code. So here's our reader, our new reader class. It creates a lexer and a parser and just calls parse. Pretty simple, really. And SwishKit now uses the reader. And no tests were changed, which I guess makes sense because it didn't change the lexer or the parser, and it didn't think it needed to create any reader tests. So let's go ahead and commit this. All right, now we've got a reader. Now I want to add support for quote. So I demonstrated quote to you before and earlier, where you just put a quote in front of a list. So let's add this up, prompt for this. Implement the quote reader macro. When the reader sees a quote character followed by any other expression, it should return a list with the first element, the symbol quote, and the next symbol, the expression that followed the quote character. So quote A would become quote A, and 1, 2, 3 would become quote 1, 2, 3. Let's add something about the evaluator. When the evaluator sees a list that starts with the quote special form, because quote is another special form, it should just return the rest of the list. All right, I think that's good. Let's go. Let's get the plan. It's reading the source files. Reading the evaluator tests. We're using Opus 4.6, so it seems to be doing a lot of thinking. Burning through the tokens. Okay, now it's going to read the parser and evaluator. Looking through the tests. That's wrong, actually. 42-A should be a invalid number because you need white space surrounded by things. But let's go look at the... Oh, okay. It's asking the question here. For the quote special form, should quote A return just quote A stand, or should it support multiple arguments like quote 1, 2, 3? Returning quote 1, 2, 3. Single argument. That's what we want. Okay, it's got a plan. And we'll check that again. Currently, quote is a symbol valid. It should not be. We're going to modify the lexer. That's wrong, which we need to tell it about. So then it's going to handle the case in the parser and the evaluator. Okay, so but let's do this. 42 quote A should be an invalid number. Numbers or any other literal should be separated by spaces. Numbers or any other letters, any other sequence of tokens should be separated by where's my cursor? Let's make sure that we've typed that in right. "42 quote A should be an invalid number. Any sequence of tokens have to be separated by white space." All right. Okay, it's going to redo a plan with separating with tokens, so spaces. Let's look at the plan again. All right, it's added in our correction. Parser is going to handle the quote, and the evaluator is also going to handle it. This looks good. All right, let's tell it to go. All right, it's updated the lexer. And the parser and the evaluator. It's a little confused about our quote character. All right, let's look through this again. Make sure it's not confused. All right, that looks good. All right, let's test this. I'm not sure if it's got the right behavior. All the tests pass. Let's run. Okay, so quote A gives me back an A. 1, 2, 3 gives me back the list A. Quote 5 is 5. 5 should be 5. A should be now an error. If I define A to 5, it now should be A. It should give me a 5, or quote A is an A. Let's look at our thing. So quote A gives me invalid number format. 42 quote A gives me A. That is correct. All right, looks good. So let's go back here. Let's say commit this. All right, it's committed. So for now, so that's it for adding the reader and support for quote. Stay tuned for the next episode where we're going to start working on some more literals, arrays and stuff. Although, we'll do that for now. We'll do arrays. At some point, we're going to have to add function evaluation for the first element of a list. So thank you and see you later.